Hey, this is Gary and welcome back to my video for making a 2D framework using LibGdx. And this video we're going to go over some more movements. We're going to go over the mouse movement, a new class in this version. And so to get the mouse movement, we need to keep track of if the button is originally clicked. I'll show what that is used for in a moment. The button ID on which we want to respond to. We're going to have a goal, X and Y, and then we're going to have a Boolean for X positive and Y positive. I'll show you how those are used in a moment. So the constructor, mouse movement, takes that button ID and it takes the speed, and then in the update method, it takes the delta time, and it's going to take this sprite update. So let me cover the sprite update real quick. So this is an interface, and basically what it's used for is to get the X and Y location and being able to set the X and Y location. And so this is using basically a visitor pattern in our update so that we can get the X and Y location and then update those. So in the mouse movement, we have our sprite update, we get the X and Y location, and then we check to see if the is button clicked has not been clicked. So we set our default goal to X and Y. This will prevent our sprite from moving before the user has clicked any buttons. Then we do a check of GDX input, is button pressed, and it checks for that button ID. We set our is button clicked to true so that we don't have to set the goal anymore. The goal X and Y is set to the screen input X and Y. From the X and Y, we call the direction, get direction. I went over this previously, where our origin is the current sprite's location, X and Y, and the goal, destination, X and Y, and we get our new direction. And then we calculate magnitudes by direction, passing in our new direction, and the speed. Now we set the X positive if our goal is greater than X, Y positive if our goal is greater than Y. I'll show you how it's used in a moment. So if we haven't reached our goal, then we do a logic of updating our location. And so we do X in X, sprite update get X, plus our X update, which is based off of this calculated magnitudes. And if we're positive, then we check our new X location. If it's greater than our goal X, then we just set our new X to be goal X. Otherwise, if it's negative, then we do nx is less than goal X, then we set the nx to be goal X. So the reason that we set X positive here is that if it's positive, then we can check to see if it's bigger than our X goal. And if it's negative, then we can see that's less than our X goal, because these two are basically the opposites of each other. So if we did like an OR condition, nx greater than X goal or nx is less than X goal, it'll always be true. And then we would just set it to the X goal and he would just pop to that location. So this way that we can accurately set it to go to the new goal. The sprite update, we set the X location to what the new X is. And then we do the exact same thing for the Y locations, just in the Y direction. So I added the speed to all of the constructors so that that will be set when you create the movement. That way we don't run the risk of not setting the speed and then kind of wondering like, why is it not moving? So we go back to our tutorial program, and then we'll create a new class. This will be a mouse movement screen. And this will extend our base screen. We'll implement our abstract methods. Okay, and now we'll pull over some attributes from our previous screen test. Get our X and Y location. And we're going to get our four-way motion again. We're going to use that same sprite. And then there's the sprite update. Get those imported. And then on our four-way motion, we'll add that. And now our sprite update. We're going to create an anonymous inner class, so it'll create all of our methods that we need. So this will just return that x from the class variable x, and then this will return the y also from a class variable. And then this one, we're going to set it to nx, ny, where x equals nx, and then y equals ny. Put our semicolon there. And then we need to add our mouse movement. And then here in our show method, do our movement equals new mouse movement. Do our input dot buttons dot left. And we'll set our speed. We're going to set it to 1. And then down in our render method, movement dot update. Pass in that sprite update. Then in our motion 1, we're going to call the update delta time, and then the movement dot get direction, and then we'll call motion dot draw. Pass in our sprite batch, and we're going to call now our sprite update dot get x, sprite update dot get y. Now since these x and y are class variables, I could have just called the class variable, but I wanted to demonstrate how to pull it from the sprite update. Go into our game tutorial, and here mouse movement screen. There's our new mouse movement screen. Alrighty, and then we'll kick that off. So there's our sprite. And you noticed I didn't set the background color, but you can see the square that surrounds that sprite. So then if I click anywhere on the screen, it will move to that location. And I tried not to move the mouse, so you can see that it's right there at 0, 0. And so now I can have it go to any location I want. And then the motion automatically updates, have it face in the right direction. And then if you click and hold the mouse button, it'll move towards your mouse automatically. And that's how that works. So the next thing we're going to do is add keys for moving the viewport around. And so I've got it all set up here. So if you press the A key, the camera will move up. If you press, the A key would move to the left, D key moves to the right, W moves up, and S moves down. So now I show you how that interacts with the mouse click. And so here's my sprite, so I can move this viewport to the different directions, right? And so if I click here, you notice that the sprite moved to a different location because I moved the viewport around. Right? And so we'll make an adjustment for that. So in the base screen, I've changed the from taking a camera to a viewport. And so when you set the screen, it will set the viewport instead of the camera. And that gives us a little more access to the viewport and the camera both, in case we need both of those. And so on the screen input, here we'll make an adjustment. So currently the get x gets the input and gets the x, and the y gets the height and subtracts the y from the input. And the screen size, now we've added the camera, and so now that's an attribute of this class. And so with the camera, we can get the position and then the x, and if we subtract half the width, because that's how we set it up when we originally added the camera's position in the base game, where it is offset so that 0 is at the bottom left corner of our window here. And so for the Y, it's now the same thing, the Y position minus half the height, and that'll put it in our starting spot. And then as we move the camera around, then it will adjust the location accordingly. And so now when you set the screen input, set the screen size, we also pass in the camera. That's upon creation. And then if you resize, it'll also re-add the camera. And then we had here, if the camera is an instance of an orthographic camera, it will set the to ortho. If it's a different type of camera, it won't set that, because this set to ortho is only on the orthographic camera. So let me set the background color to white here so we can see it. So I'm going to add another animation for demonstration purposes. And then we're going to add another sprite update. Now the sprite update is not how we're going to kind of render our sprites in the future. We'll get into that in a little bit. So here I've added a sprite update for our new animation with its own X and Y coordinates. And so that new animation, right, that's this guy. We'll create a new block animation, and we'll just make it 5 by 5. That should be sufficient. And we'll set its color. We'll just use blue since it's right there at the top. And what we'll do is we will listen to inputs, right? And so if key, and we'll do if button is just pressed, input buttons, and then we'll use the left button. And so when the button is clicked, we'll do our sprite update 2. We're going to set the X based off of our screen input. Then we'll get the X, and then we'll do the same for the Y coordinates. I get the Y. Now, first, for demonstrating purposes, I'm going to set it back to what it was originally. So then in our mouse movement, we'll do our animation. We'll just draw it based off of our sprite 2.get the X, our sprite update 2.get the Y. And so you can actually see where we're actually clicking. So I'll run that. So I click here and watch the sprite move up to that location. And I move the screen around, right? And I click there. See, I didn't move the mouse, so it's trying to go the exact same place. Now we'll go to our new implementation. We got our mouse movement. We're doing the screen inputs, X and Y update. And then we'll run it. So I click it here with no movement. It's coming to where I want it to be. I move over here, go down a little bit, and you can see it's now going to the new location. So even though I move the screen, say I'm moving off to the left and the down, still moving towards where the mouse is clicking on the screen, even though my viewport is changing. And that makes the correction so now that it will move as the viewport moves. Okay, now we're going to go back into the animations, and we're going to make an update for doing what's called translucency. Sometimes people call it transparency, which is the amount of how much you can see through a particular image. That's the translucency. And so I've added another method to our animation object for setting the translucency. One is non-transparent, non-translucent at all. It's the regular image as itself. and 0 is fully transparent, so where you can't see anything. And so I've added a translucency field to the base animation. So in the base animation, I've actually made an update to setting the colors. So those color constants that show up in the color object are not actually constants. They're just objects with a default value, and you can actually change those values. And so even though you set the value to say color.white, you can actually change it to be not white color, any other color that you want. So I fixed that by creating new colors every time we set the color. And so we have the method for setting the translucency, which is a percentage from 0 to 1. And as long as the translucency is changed, then it will go through. If it's over 1, it just makes it 1, because you can't make a more opaque than 100%. And less than 0 doesn't make any difference either, because it's fully transparent at that point. So it keeps it between that 0 and 1 range. And if the color is null, it will set the color as white after it sets the translucency. Otherwise, it'll just set the color, and the set color methods now take the values out of that color object and also add in the translucency, creating a new object. And another thing that I have done in the motion object, since the motion object really is just a kind of like a holder for the animations, so that you can have multiple animations and moving in different directions, I've added the methods for setting the color and setting the side and setting the translucency to the motion interface. And so I've updated the other motion objects, and these new methods are pass-throughs to the animation object, and so it will call the methods, corresponding methods on the animation object within. And so for the four-way animation, when it gets the height, it takes the current animations index to get the height and the width, and when you set the color, it will loop through all of them to set the color, as well as the translucency. So let's move into our motion screen here, and what we'll do is we will take our sprite, our movement guy, and we're going to set a translucency for it. And so here's our base character. And so for motion 1, we're going to set translucency. We'll just set it to 0.4, which is 0.4. And we will run that. And so you can see that the character is now semi-transparent, translucent, not fully colored. And so that's how translucency works. And let's say that you wanted to have like a wall and have your character walk behind the wall, and you want him to appear like he's translucent when he walks behind the wall. So we'll kind of demonstrate that. We'll create a wall animation. And we'll come down here. Wall animation is going to equal a new static animation. And I have a texture called wall.png. And we're going to set up our wall animation here. So we'll put it here at 2 and at 5. So here's our wall animation, right? And so you see this character has a block around her. So I'm going to bring in a different animation for our demo character. So this is a PNG image. And then this doesn't have that block around there, so that we can see them being transparent. And so what we can do, we have an if check here. If our sprite update get x is greater than or equal to that 200 location, and we need to also subtract the width of the character so that once they hit the edge of it, they'll become translucent. And then when they get to the other side, our wall is 20 pixels wide. Take our motion, set our translucency, and then if it's not in those areas, then we're going to set it back. Okay, and then we'll show you what that looks like. So he does become translucent, or she becomes translucent, but as you can see, it's the entire character. And so that doesn't make them look like they're walking through the wall as one would expect. So an alternative, one would think, to make the wall animation translucent. And so this is how that looks. So now the wall is translucent, but your character is full opaque. And that's not what we want either. And so the workaround for that would be to create a second animation. So we'll make a wall animation 2. And this is also going to be a static animation. And we'll just get the wall again. And this guy, we're going to set his translucency at 40%. And then we're going to have our motion. We're going to move this guy up. And then we're going to go to wall animation 2. Since his translucency is already set to 40%, we're going to draw, put him at 205, same as the other wall. And otherwise we're not going to do anything. And so now we're going to draw the full opaque wall. Then we'll draw the motion, the sprite moving across the screen. And then on top of that, we're drawing the translucent animation wall on top of it when the character is in range. And this is how that looks. So now you can see the wall is partially transparent, and since the wall is on top of that, it kind of makes the character look like they're partially transparent. So we can go a little bit better. We can do 60%. Now it looks like they're behind the wall essentially. And so that's our transparency, and that's how that works. So the transparency, you can either have it render that wall section all the time, or just have it render when the sprite, your character, is going through that wall. So it's really kind of up to you. I kind of choose to not over render stuff, and so that's why I've set it up to kind of only render it when it's actually the sprite is going over that. So that's going to do it for this video. So in a couple weeks I'll have a new video, and until then you can hit that like button or subscribe, and we'll see you in the next video.